Okay, good. So we were doing quadratics and we were done with a few concepts of this topic already. After today, you should be able to do most questions from the worksheet, almost all of them. So you would have a couple of days after this to practice then, and then Thursday, you can let me know if you have any problems from the questions in the worksheet. Okay. So what have we done until now? In fact, I'll just focus on what we did in the last session. In the last session, we actually just did some practice questions. And one of the key concepts before that was of the discriminant, that we have three primary cases here. Discriminant is greater than zero when you have two real and distinct solutions from some quadratic equation. And when you have two real and equal roots, or you could also say there's only one real root because those two roots are equal, you would say b square minus 4ac is equal to 0. And when there are no real roots, you say b square minus 4ac is less than 0. And then there are corresponding understandings of each of these cases graphically as well. The first case means that the line and the curve, they intersect at 2 points. The second means the line is a tangent to the curve, which means it only touches the curve at 1 point. And the last one means that the line and the curve, they do not intersect at all. Now, one case that we haven't found in our practice questions yet, but we will be doing some questions like that in the next class, hopefully. That is that sometimes they say they are real roots without specifying how many roots. It could be one root, it could be two roots. In that case, we say b square minus 4ac is greater than or equal to 0. It's a combination of the first two cases. Okay. Or graphically, they could say that the line meets the curve without specifying at how many points. It could be 1 point, it could be 2 points. In that case as well, you say b square minus 4ac is greater than or equal to 0. So this was one major concept. Most of the other concepts you had in some way covered in O levels as well. But of course, we did some new methods for those concepts as well, which I hope you found helpful. Now, today we are going to focus on how we can solve quadratic inequalities, first of all. Quadratic inequalities. All right, so this is going to be something new that you have in this topic. Quadratic inequalities. Now, we already know how to solve quadratic equations, right? So if you have an equation that looks like this, for instance, if you have x squared minus 7x plus 12, if you have a function that looks like this, let's actually focus on this for now. Let's say you have a function that looks like this. So how does the graph of this function look like? This graph is a U-shaped graph like this, right? Coefficient of x squared is positive, so it's going to be a U-shaped graph that looks like this. And this might have some x-intercepts like this. In this case, it does have x-intercepts, I know that. Sometimes they don't exist as well, but in this case, they do. So the graph is actually going to look like this. This is going to be the x-axis, and then you have 2 points of intersection. How do you find these 2 points of intersection? How do you find the x-intercepts of a function? You put y equal to 0, right? So if you were to input y equal to 0 here, what would you get? If y was equal to 0, you would get an equation like this: x squared minus 7x plus 12 equal to 0. That is what gives you the x-intercepts of this graph. You could solve this quadratic equation. When you solve this, you'd get some values of x, and they would the values of x that you get graphically, they're going to represent the points of intersection that this curve has with the x-axis. Okay. Now let's solve this equation. How would we solve this equation? In this case, we can factorize this. We can say x squared minus 4x minus 3x plus 12 equals 0. Then we get two factors from this: x minus 4 and x minus 3, which gives us either x equals 4 because x minus 4 equals 0, or x minus 3 equals 0. And the first one gives us x equals 4, and the second one gives us x equal to 3. These are the two x-intercepts that we get from this. Graphically, we would say that this value here is therefore 3. That's the smaller value, the one on the left side, that's going to be 3. And the value on the right side there, that is 4. These are the two x-intercepts that we get from this. Okay. Now the question is, instead of this equation, what if we had an inequality instead? What if we had an inequality that looked like this? For instance, x squared minus 7x plus 12 less than 0, for instance. What if we had an inequality like this? What if we wanted to solve this inequality? What would we do for this? We could potentially apply the same process, same method, right? Factorize it. X squared minus 4x minus 3x plus 12, that is less than 0. Then we get two factors from this, x minus 4 into x minus 3 less than 0, right? That's what we get when we factorize this. And then we might think that since the product is less than 0, that means x minus 4 is less than 0 and x minus 3 is less than 0, right? But this is not going to work because this gives us x less than 4 and x less than 3. And I'm telling you, this is not going to be the correct result. So what you used to do with equations, that you could split these factors like this, that either x minus 4 equals 0 or x minus 3 equals 0, if you had a product equal to 0 like this, you cannot do the same thing in an inequality. Now, can someone try to explain why we can't do it here? Well, when we could do it in an equation, why doesn't this work in this case? Any idea about this?
Sir, because of equality sign.
Because of equality sign. So we could do that step in the equation, but we can't do here. Why not? What's the problem?
Sir, because it's less than 0, and we could do it up there because it was equal to 0. Since this is less than 0, it's going to be a negative number.
Yes, it's
Sir,
less than 0, so
it doesn't
yeah.
fulfill the inequality if we use this method.
It doesn't fulfill the inequality. Yeah, so one possibility is that you try inputting these values. If x was less than 4, you could try inputting the value of 5, for instance, right? X less than 4, that means one possible value of x would be 5. X less than 3, so 5 satisfies both conditions, right? So we can input 5. 5 minus 4 into 5 minus 3, that's a positive number. It's not less than 0. It doesn't satisfy the inequality. But why is that? Let me quickly give you the logic for this. Well, in an equation, we could do this. And we have talked about this before, that when we have a product and the result is 0, it's necessary for one of these two to be equal to 0, because a product cannot be 0 if one of these numbers at least is not 0. So that's why we say either this is equal to 0 or this is equal to 0. That is the only possibility to get 0 as the result, right? If two expressions multiplied give you 0, that means one of them has to be 0 at least. Okay, that's why we could do that in an equation. But what are we getting in this case? In this case, it says there are two expressions. One is this and the other is this. When they are multiplied, the result is less than 0. Less than 0, what does that mean? Less than 0 means you have a negative answer, right? What we are getting from this method is that if the result is negative, then each of these should also be negative. what we've done here is we are basically saying then the first one should be negative or the second one should be negative. Is that going to give you a negative answer? It's not going to give you a negative answer, because what if both of them were negative at the same time? If the first was also negative and the second was also negative, the product would actually become positive, and that does not satisfy the inequality. Okay. So for the product to be negative, one of these factors has to be positive and the other has to be negative. Okay, any one of them could be positive and the other then would have to be negative. So if one is positive and the other is negative, then the result could be negative. So we can't do it the same way like we used to solve equations. Okay, it's not going to work here. So what instead do we do in this case? So this is what we do not have to do. Okay, so this is important because a lot of students just end up doing it this way, and that is incorrect. That will not that will of course not be correct. So this is not correct. You cannot do it this way. Okay, this is not going to work. So what are we going to do instead? We're going to think of this graph instead. So in this equation, what were we looking for? We were looking for the x-intercepts. That, okay, this is the graph that we've got. When is this graph equal to 0? When is the y value, because remember we put y equal to 0 here. When is the y value of this graph equal to 0? Y value of this graph is equal to 0 at this point and at this point. Now instead of that, we have an inequality. Let me write that inequality down here. So I'm actually going to hide this. Let me just take it to the right side. It stays in the notes, but on the side. Let me write that equation, that inequality down here again. The inequality that we were trying to solve was this. X squared minus 7x plus 12 less than 0. This is the inequality that we want to solve. Let me just copy this graph down here. This is the function that we've got on the left side. This is the function, right? This is what y was, right? Y was equal to this. We are saying when is this function less than 0? That means when is the y value of this function less than 0? Earlier we were saying when is the y value equal to 0? That was giving us these 2 points. Now we know y value is equal to 0 at these 2 points. But when is y value less than 0? So we have this less than sign. So if you look at the graph, when is the y value less than 0? That means below the x-axis. That's this region. This is the region where the y value is less than 0. So what are going to be the solutions of this equation then? Remember, this inequality has values of x. So what values of x would satisfy this condition that the curve is below the x-axis? This is the region between 3 and 4. How are you going to write it? You'll say x is between 3 and 4. Okay, x is greater than 3 and it's less than 4. And that would be the solution to this inequality. Okay, you would not, so this is an important point, you would not write it separately like this. You don't say x is greater than 3 or x is less than 4. Don't write it separately. It's a single region. It's a single region. You have to write this as a single inequality. As a single inequality that looks like this. You'll say x is between 3 and 4 together as a single inequality. Okay? Yes, Abdullah.
Sir, we need to first put the equation equal to 0 to find 3 and 4, the x-intercept. Then we will say that it is between the below x-axis.
Exactly. So first of all, you have to do this process. So in this case, we had already done this. So assuming that we already know those x-intercepts, then we do this. Okay. So first we have to find those x-intercepts. We will go through that whole process. For now, we're just trying to understand the logic of it. Now I'll write down the whole process that how do we go about it. But yeah, so for you first have to find the x-intercepts. Once you have those x-intercepts, then you think of the graph that, okay, you want the region below the x-axis. What are the possible values of x for that? It should be between 3 and 4. Okay?
Sir, can we
Yes.
use the turning point to find it?
How would you do that?
Sir, like at one point the curve will be at decreasing, at the other end it will be at increasing. So uh, can't we do it?
What does that have to do with the inequality here? Turning point is this point here. I don't understand how that would be relevant. Turning point can, yes, tell you that, okay, the curve is below the x-axis at that point, but it's not necessary. Once you know it's a U-shaped curve, you understand that, okay, between those 2 points, it's going to be below the x-axis. I don't see why it would be necessary to use the turning point there,
Okay, sir.
right? Okay, let's have a look at another inequality. Let's say it was like this: x squared minus 7x plus 12 greater than 0. Let's say we had an inequality like this: x squared minus 7x plus 12 greater than 0. Okay, what about this inequality? What about this inequality? Let's have a look at this now. Okay, now okay, just give me a minute. I'm sorry, I'll be back. Try this. I'll be back in a moment. Okay, I'm sorry. I just need to take care of something. Okay, so I hope you've tried this. Can all of you let it be the result of this inequality? What would you get from this? So now it says x squared minus 7x plus 12 is greater than 0, right? So you look at the graph and see where is the y value of this graph greater than 0? Where is the graph above the x-axis? What region is that? That's this region here. And this region here, right? These are the two regions that we have. So yeah, so that's correct. So most of you are giving me the correct result. So there are two regions that satisfy this. One region is to the left of 3, and the other region is to the right of 4. These are the two regions. That means x is either less than 3 or it's greater than 4. These are the two possible regions that satisfy this inequality. Now, this is something that you cannot write as a single inequality, okay? This has to be written as two separate inequalities, because on the graph, these are two separate regions. You have one region on the left side, less than 3, and you have one region on the right side that's greater than 4. The number of regions are 2. The inequalities also have to be 2. In the first case, it's one single region. It has to be written as a single inequality. This would be your answer in the first case. In the second case, it would be two inequalities like this. Again, a common error here is to write it like this instead. You might say it's less than 3 and greater than 4. Yeah, so some people write it like this, I think. Or maybe like this, in fact. They would say it's greater than 3 like this. No, less than 3. Is it like this? And then, yeah. So some people actually end up writing it like this, that x is less than 3, x is greater than 4. This is not correct. You cannot write it like this, because if you write it like this basically means that x is at the same time less than 3 and greater than 4. That does not make any sense. A number cannot be less than 3 and greater than 4 at the same time. That cannot happen, right? When you write these separately, there's an or between them, that either x should be less than 3, that is one possible case, or it should be greater than 4. That's the correct way of writing this. You cannot write it as a single inequality. That is not correct, okay? So you can just remember it this way. When it's a single region, you have one inequality. When it's two separate regions, you have two separate inequalities. All right. And that's going to be the solution of this inequality then. All right. I hope that makes sense. Now, let's go through a formal process of solving quadratic inequalities. Let's take another example now and understand how we're actually going to go about this whole process now. So let me write down an inequality. Let's say we have something like this. We have 2x squared minus 7x minus 4 that's greater than or equal to 0. Let's say we wanted to solve this inequality. Now, what do we do for this? The first thing that we need to do is we need to find the x-intercepts of this inequality, right? The x-intercepts of this function that we have, this function. So for that, what we would do is we would say, let's treat this as an equation, first of all. You treat this as an equation. Okay. When you treat this as an equation, you get 2x squared minus 7x minus 4 equal to 0. Okay. Now, when you treat this as an equation, what you have to do is you have to treat this as an equation to find the x-intercepts. Right? That's the purpose of doing this. Now, this is an equation that you know how to solve, right? We've done this so many times. You've been doing this since O levels, in fact. How would you solve this? You can factorize. You can say it's 2x squared minus 8x plus x minus 4 equals 0. You take 2x common from the first two terms. That leaves you with 2x minus 4 inside plus 1. No, I'm sorry, it should be x minus 4. X minus 4 inside and then you have plus 1 into x minus 4. You get two factors. One is 2x plus 1, and the other is x minus 4. So that means either x equals minus 1 over 2 or x equals 4. Now, these are the two x-intercepts that you have. Okay, these are the two x-intercepts. Now what you can do is you can draw a rough sketch of this function. This is the function. It's a U-shaped graph, right? It's a U-shaped graph. That means it's going to look like this, right? Roughly, that's going to be the shape. What you have found is the x-intercepts. This is one intercept, minus 1 over 2. And the other is 4. Okay? These are the two x-intercepts. We have found these x-intercepts. Now, what does the question say? It says greater than or equal to 0. Where is the y greater than or equal to 0? It's this region or this region, right? That's the region where y is above the x-axis, where the graph is above the x-axis. So these are the two regions that you're going to consider. So if you consider the x values, this is one region, this is the other region. You say x is either less than or equal to minus 1 over 2. That's one possibility. Or x is greater than or equal to 4. These are the two answers that you get from this. Now, why are we using equal to sign here? Because the question statement, the inequality in the question statement has an equal to sign as well. So in our answers, we are also going to have this equal to sign included along with the inequality. Okay, so this is the solution that we get from this. So the first thing you do is you treat as an equation to find the x-intercepts, and then once you've done that, you use a graph to basically figure out which region or regions are going to be correct. Is that okay? Any question on this? Let me write down another inequality now. I'll give you a couple of minutes to think about that and solve that. So what if I had something like this? Minus x squared minus 7x minus 12. That's greater than or equal to 0. What if we wanted to solve this inequality? So take a couple of minutes and let me know what the solutions are for this inequality. Can all of you try this, please? I want answers from each one of you. Abdullah, Arham, Aisha, Ira, Hazim, Maheen, Rajal. All of you need to write down your answers in the chat box, or you can let me know verbally what the answers are. In fact, write them in the chat box so you don't tell others the answers. So write down your answers in the chat box. All of you should do that. Yes, I don't have any answers in the chat box yet. It was not that long. What are you getting? Okay, so Rajal, that's good. You would also include the equal to sign, remember, because the question has it. Hazim, that does not seem correct. Think about what's the smaller number, what's the large number out of the two roots that you've got. Arham, are you sure you're going to write them separately like this? And are the values correct? They don't seem to be correct as well. Abdullah, are you sure you're going to write them separately like this? Aisha, Ira, Maheen. Maheen, we're not solving an equation. It's an inequality. They would be the cutoff points, the x-intercepts, yes. But what about the solution of the inequality? Aisha, Ira. Okay, Ira has given me a solution there. One of those values is wrong, Ira. Abdullah, almost, but check again. It's maybe the opposite of what it should be. Okay, good. Let's try this. So good that all of you tried. Now let's have a look at this. How are we going to solve this? Minus x squared minus 7x minus 12 greater than or equal to 0. Now there are two ways of thinking about this. One is just treat this as an equation as it is, right? Directly, the first thing you do is you treat this as an equation. What happens when you do that? It becomes minus x squared minus 7x minus 12 equal to 0, right? So we treat this as an equation like this. Okay, to find the x-intercepts. Now, how do we solve this equation now? We have negative signs with all the numbers. What we can do is to make it easier, we could multiply by -1 if we wanted. Multiply the whole equation by negative. That will make it x squared plus 7x plus 12 equal to 0, right? That makes things easier. Generally, we like having the coefficient of x squared positive. That makes things easier to work with. Now we can factorize this. 7x can be broken into two parts like this: x squared plus 4x plus 3x plus 12, that equals 0. The first factor is going to be x into x plus 4. Let me actually first factorize it like this. Then the two factors turn out to be x plus 3 and x plus 4. So what are the two x-intercepts that we get? We get -3 and -4. Okay, these are the two x-intercepts that we get. But this is not the final solution. This is not the solution of this inequality. These are the solutions of this equation that we solved. Okay, now let's sketch this graph. How is the graph of this function going to look like? The coefficient of x squared is negative. The graph of this function would actually look like this. It's an n-shaped graph, right? It's an n-shaped graph. And this is the x-axis, let's say. What are the x-intercepts? One of the x-intercepts is -3 and the other is -4. But remember, what's the smaller number? -4 is the smaller number, -3 is the bigger number. So -4 should be here and -3 should be here, right? -4 is going to be on the left side, -3 is going to be on the right side. Now let's look at the inequality. It says greater than or equal to 0. Where is the graph above the x-axis? Where is the y value greater than or equal to 0? That's this region. What values do we consider? The region between these two numbers. So the solution therefore is x is between -4 and -3. So x is greater than or equal to -4, which is also, and it's also less than or equal to -3. So it's between these two values. Yes, Arham, that's what we get. Between -4 and -3, that will be your final solution. Is that okay? That's the result that we get from this. This is one way of doing this. Another way of doing this could be that we change the inequality first of all before making this an equation. So this is one possibility, and this is perfectly correct. There's nothing wrong with this. This is a method that you can use. Another thing that we could also do is we could first make the coefficient of x squared positive. Yes, when we do that, that will change the sign as well. That's correct. So that's going to change the sign as well. So if we make this positive here, if we make the coefficient of x squared positive here, we have to multiply the whole inequality by negative. That will make it x squared plus 7x plus 12, but we had greater than or equal to here. That's going to become less than or equal to 0 now. But these are equivalent equations. What we're doing now is we are looking at this inequality now rather than the first one. Okay, so the sign that we use is going to be this one now. And if we use this function, the graph of this function is now a U-shaped graph. This is what the graph is going to look like in this case, right? Because now we're looking at this function by multiplying it, after multiplying it by -1 first of all. Now we do the same thing that we did above. We treat this as an equation. X squared plus 7x plus 12 equal to 0. And then you factorize this. This gives you x plus 3 into x plus 4, like before. X equals -3 or x equals -4. You get two factors, two x intercepts. This one is -4, this one is -3. And now we have less than or equal to sign, and we have a U-shaped curve. Where is the graph below the x-axis here? That's this region. This is where the graph is below the x-axis, because now we're looking at this inequality, not the original one, because we have changed that. If we are using a U-shaped graph, then it has to be less than or equal to here. What's the region that we get from this? You get the same region, same answer. The values that are between -4 and -3, the result turns out to be x between -4 and -3. And that's the result that we get from this as well. So we get the same answer at the end. You could approach it in any of these two ways. So you could first change the inequality sign by making it positive, or you could, or you could just treat it as it is. And in the first case, as in without changing the inequality sign, that was one possibility. And the other possibility is you first make this negative positive, but that will also change the inequality sign, and then use that changed form. That's also going to work. So you can use any of these two methods, they're going to work. Okay, so when you have a negative sign there, this is what you would do in that case. All right, any problem with this? Any questions? Any problem with this? Okay. Now, this idea of changing the graph to a U-shaped graph is pretty helpful in speeding up this process of solving inequalities, because think about it. If you had a U-shaped graph, if every time you got a U-shaped graph, for example, even if you had an N-shaped curve like this, if you multiply this by the negative sign, it becomes a U-shaped curve, right? If you were to convert every inequality to a form such that the coefficient of x squared is positive, you would always get a U-shaped graph, right? So what we could do is we could say, whenever there is a less than sign, we are going to choose. So if a and b are the x-intercepts, whenever there's a less than sign or a less than equal to sign, we're going to choose the middle region. And whenever there is a greater than sign, we're going to choose the regions on the sides. So less than would always be in the middle, and greater than sign would always give us the regions on the sides. So that is a way to basically do it without drawing the graph sometimes as well. So if you've done enough practice, you would figure out sometimes you can actually skip drawing the graph and write down the answers directly. How would that work? I'm just going to give that process to you. If you think you're one of those that you can just figure it out yourself without having to draw the graph like this is how you would think about it. That whenever the coefficient of x squared is negative, what you do is you make it positive by multiplying the inequality by -1, just like we did here. We multiplied the inequality by -1. You make the coefficient of x squared positive like this, right? When you do this, remember, the inequality sign is also going to change. The inequality sign would also change in this case. So you have to be careful about that. The inequality sign would also change. Keep that in mind. That's the first thing that you always do. So whenever you're solving a quadratic inequality, this is one way to go about it. If the coefficient of x squared is negative, you make it positive first of all by multiplying the inequality by -1, just like we did here. In this case, the coefficient was negative. We multiplied the inequality by -1, and we also changed the sign. Okay. What do we do next? We just do the same process as before. You treat the inequality as an equation. To find the x-intercepts. Okay, you find the x-intercepts by treating the inequality as an equation. And now what you can do is you sketch. Now this step can be skipped if you want. Sketching part can be skipped. You can actually do it without that as well. You could sketch it if you want, or you could do it directly. I'll tell you how. Sketch a U-shaped graph. Why a U-shaped graph? Because you'll always get a U-shape in this case. If you've already made the coefficient of x squared positive, you will always have a U-shaped graph, right? You sketch a U-shaped graph to see which regions are correct the direct way of doing this could be If you have less than or less than or equal to sign, the region in the middle would be correct, because a U-shaped graph is always going to be below the x-axis between these x-intercepts. And if you have greater than or equal to sign, the regions on the sides will be correct. Now, let me repeat. How do you solve an inequality? This is a process that you can use for every kind of quadratic inequality. If the coefficient of x squared is negative, you make it positive by multiplying the whole inequality by the negative sign. That will also change the inequality sign, remember. This is only if the coefficient of x squared is negative. Mostly it would be positive already. In that case, you move on to the second step. Okay, first step is only if the coefficient of x squared is negative. You only have to do it in that case. Otherwise, you don't do anything with that. Okay. Then you treat it as an equation to find the x-intercepts. Since you would have already made the coefficient of x squared positive, it would always be a U-shaped graph. And in a U-shaped graph, if you have less than or equal to sign, the region in the middle will be correct. The region in the middle of these x-intercepts will be correct. And if you have a greater than or equal to sign, the regions on the sides will be correct. Okay. So if, for instance, we had x squared plus 7x plus 12 greater than or equal to 0, this was one inequality that we saw above, right? You treat this as an equation, or let me actually make it negative first of all. So let's say it was like this. Let's say it was like this. What's the first step you do? You make the coefficient of x squared positive and multiplying the whole equation by negative sign. X squared plus 7x plus 12. Remember, this sign is also going to change. So it becomes greater than 0. Now, this is the sign that you're going to look at, not the original sign. This is the sign that you're going to look at. Treat this as an equation that gives you x squared plus 7x plus 12 equal to 0. You get two factors from this. X plus 3 into x plus 4. Two x-intercepts, minus 3 and minus 4. All right. Now, since it's a greater than sign, which regions are going to be correct? The regions on the sides. The region to the left of the smaller value and to the right of the larger value. What's the smaller value out of these two? Minus 4 is the smaller value. So you say x is less than minus 4. Minus 3 is the bigger value. You say x is greater than minus 3. Okay. If you understand this, that's great. If you find this confusing, this is going to be safer. Just sketch the graph. Just sketch the graph and see from the graph which regions should be correct. So this is the graph. This is -4. This is -3. You're looking for the region that's above the x-axis. That's this region and this region. So it's either to the left of -4 or to the right of -3. These are the solutions that you get from this. You have to make sure that you write them as separate inequalities because these are two separate regions like this. Okay, so that's the process for solving quadratic inequalities. Let me know if there are any problems. We are now going to have a look at one quick question from the worksheet. If you don't have any problem with this, let me know if there are any issues. Anyone? Any questions, anyone?
No, sir.
Okay, good. Now let's have a look at one question from the worksheet then. that involves solving quadratic inequalities. So now you should be able to do pretty much the whole worksheet, right? We're just left with hidden quadratic equations or disguised quadratic equations. Apart from that, you can do everything. And that's most of the questions from the worksheet. So I would really hope, I would expect that you would be done with those questions before Thursday, so we can discuss any problems that you have on Thursday. Let's have a look at one of these questions very quickly. Any equation, any question that involves an inequality. There was one that actually somebody asked about earlier. Yeah, question number 5, for instance. It's a relatively straightforward one. It's only one part, 5 marks. Let's have a look at this. How would you approach this? Question number 5 from the worksheet. It says find the set of values of m for which this line intersects this curve at 2 distinct points. Does that remind you of something? Intersect at 2 distinct points. That means b square minus 4ac is greater than 0, right? If there are 2 distinct solutions, b square minus 4ac is supposed to be greater than 0. That's what we have to use. Now we have a curve, and that curve looks like this. Y equals 3x squared minus 4x plus 7. That's the curve. And the line is y equals mx plus 4. Remember, how do we start? The first thing we have to do is we have to equate these two functions and then convert them to a form like this: ax squared plus bx plus c equal to 0, so that we can find b squared minus 4ac from that. So first of all, we have to equate these two. Let's equate the two. We get 3x squared minus 4x plus 7. That is equal to mx plus 4. All right. Now we take everything to one side. We can take them to the left side. That gives us 3x squared minus 4x. We write the like terms together. So x terms together, that gives us minus 4x minus mx, then plus 7 minus 4, that's plus 3. This equals 0. We need this form. We need some coefficient of x squared, some coefficient of x, and a constant term. Coefficient of x squared is 3, so we have 3x squared. What about the coefficient of x? We can take x common here. That leaves us with minus into 4 plus m as the coefficient. So this whole thing is the coefficient of x minus into 4 plus m, and then the constant, which is plus 3. All right. Now we say, let's find b squared minus 4ac from this. What's a? A is going to be 3. B is going to be minus into 4 plus m. And c is going to be 3. These are the 2 values that we have, 3 values that we have to input here. B squared minus 4ac is supposed to be greater than 0. Why? Because the line and the curve, they intersect at 2 distinct points. So now we just input values here. In place of b, we write minus into 4 plus m, and then whole squared, right? Minus 4 into 3 into 3. That is supposed to be greater than 0. And now we need to solve this inequality. This is a negative sign, and we have whole squared. So the negative sign gets removed because it's common outside, right? We're just left with 4 plus m whole squared. Minus 4 into 3 into 3, that's 12 times 3, which is 36. That is greater than 0. Now we could actually solve it by taking square root, as in if you were to treat it as an equation at this point and then take square root by first taking 36 to the right side, that could work as well. But in case that makes things complicated for most of you, what's going to work is just expand it. 4 plus m whole squared. We can expand it. A plus b whole squared, that's a squared plus 2ab plus b squared. 4 squared, what's that? That's 16. Plus 2 into 4 into m, that is 8m. Plus m squared minus 36, that is greater than 0. And this gives us m squared plus 8m minus 20 greater than 0. This is a quadratic inequality that we have now. Now we just need to solve it as a quadratic inequality. We just learned the process for this. This is what we have got. So what did we do? We equated the two functions. That's how we used to start, right? We equated the two functions. Then we put b square minus 4ac greater than 0. Okay. And we got to this quadratic inequality. Now we need to solve this quadratic inequality. How do we solve quadratic inequalities? We say, let's treat it as an equation. So it becomes m squared plus 8m minus 20 equal to 0. We just have m instead of x here. We are used to using x in inequalities. Here we have m. The process remains exactly the same. There's nothing different in the process, right? We treat this as an equation. Now solve this equation. Can we factorize this? Well, it seems we can. It becomes plus 10m minus 2m minus 20 equals 0. That gives us m into m plus 10 minus 2 into m plus 10. And there are two factors that we have, m minus 2 into m plus 10. M is either equal to 2 or m is equal to minus 10. These are the two cutoff points that we get, okay? The coefficient of x squared in this inequality, that's positive. So this is going to be a U-shaped curve. We're talking about this curve, this function. This is a U-shaped function, and it's going to look like this, right? This function is m squared plus 8m minus 20. This function has 2 points of intersection with this horizontal axis, which are going to be minus 10 and 2. Remember, minus 10 is the smaller value. Minus 10 should be here, and 2 should be here. What sign do we have? We have a greater than sign. So we are basically looking for those parts, looking at those parts of the graph which are above the x-axis. So it's either this part or this part. So what are going to be the solutions? To the left of minus 10 and to the right of 2. So we say m is either less than minus 10 or m is greater than 2. We write it as two separate inequalities because we have two separate regions. So m is either less than minus 10 or it's greater than 2. This is going to be the solution that we have from this. Is that okay? Any questions on this? All right, I hope that makes sense. You can let me know if there are any problems. So this is what happens. We put b square minus 4ac greater than 0 in this case. Sometimes you will be inputting that less than 0, sometimes greater than or equal to 0. And then you can solve those inequalities using the process that we have just learned. Okay. Now, let me see if we could perhaps have a look at another one quickly, or maybe not because of its 25, 26. Okay, let me actually do this. Let me show you a couple of more questions. In addition to this worksheet, I've actually uploaded a couple of extra questions on the on Classroom as well. But in addition to that, I would want you to solve a few others as well. I'm going to copy them from somewhere here. They are good questions, and they're not part of the worksheet. They're from some recent papers. Let me just add these questions here. So I would recommend that by Thursday, you try some of these questions as well. I'm adding these to the OneNote notebook. All of you, by the way, have access to these notes. The link for these notes is in the WhatsApp group. They update in real time. I would highly recommend that you have OneNote app downloaded on your phone, on your laptop, on your tab, whatever devices you use, so that you have all of these notes available with you as well. Okay, download the OneNote app, just click on that link then, and that will open it in the OneNote app. Sometimes it does not open the link in the OneNote app. Instead, it opens it in a browser, Safari or Chrome. And the browser version of OneNote is extremely slow. You would not find that helpful. That lags a lot. So make sure that it opens in the OneNote app that you have downloaded. Okay. So you need the OneNote app downloaded. And if it still doesn't open there, also download OneDrive, because sometimes it's connected to OneDrive, especially on a phone. So you would need OneDrive application downloaded as well. Then it will open on the app, and that looks exactly as it looks here. It's very well structured. So you have notes of the first class here. Then we're talking about discriminant here. Then some questions. Question number 148. You can see which questions we did in class. They're working. All right. So all of that is going to be there. So make sure that you have that downloaded. Now, these are some questions that I would actually want you to do as well. Let me get rid of the working from this. So these are taken from some recent papers. They're not in the worksheet. Please try these questions as well. So I'm showing this to you here. You can take a snapshot if you want. So you also have to try this question. Okay. In addition to the assigned questions from the worksheet, then you have another one, which is this. No, don't take a snapshot before I remove the solution. Yeah, so now you can take a snapshot here. You have to try this as well. Okay. Then there's another one. The first part of it is more important. Yeah. You have to do this as well. Again, you can take a picture or a snapshot. And then finally, this one. This is also from a recent paper. These are good questions. There is one new concept here as well that we will be able to understand using these questions. So take a picture of this as well. These 4 questions you should also try before our next class. Okay. No, these are not this year's, but these are mostly from the last 3-4 years. The worksheets are until 2016 mostly. So that's why I told you earlier that once you're done with the assigned questions and the questions that we do in class, your concepts will be all done. But then for extra practice, you should be doing a lot of recent papers. So what you can do is you can start from 2022 papers. What did I say? 2022. Yeah. So 2022, you start from those papers, then you go to 2021, 2020, go backwards and go as much back as you can. And then leave the 2023 papers for the very end. You can do them in April at some point. But you should start from 2022 papers and go backwards as much as you can, all variants. That is what you should be doing after you're done with the assigned questions from the worksheet. Okay. So please try these questions as well, in addition to the assigned questions. All right. Arham, we are not going to do functions next, unfortunately, because there are some people who are taking both P1 and P3. So what I need to do is I need to cover some specific topics of P1 that are required in P3. For example, trigonometry, differentiation, and integration, because otherwise we can't do P3 trigonometry, P3 differentiation, and P3 integration if we do not know the P1 concept. So I'm going to try as much as we can to finish those 3 topics in particular, differentiation, integration, and trigonometry first from paper 1. And then we might actually have to leave functions, function transformations, AP and GP for the end, perhaps. Circular measure as well, although that's a pretty small topic. So we will be prioritizing trigonometry, differentiation, and integration first, okay? So the next topic is going to be coordinate geometry because we will need that for, we have to think about that as well. Coordinate geometry will need gradients and equation of line, not equation of circle. Yeah, so we might actually, I might just revise a few concepts of coordinate geometry in one class, and the one that the concepts that you've done in O levels already, because we just need those concepts for trigonometry, differentiation, and integration. So we will be doing those topics first: trigonometry, differentiation, and integration, and then we'll be doing the rest of them: coordinate geometry, APGP, functions, and function transformations. All right, so that's going to be the order pretty much. Okay. But yeah, so I'll be trying to complete this latest by the first week of April. So that's like the latest that we could go up to, but we could most likely have some extra classes during the next 2 months. So we could try to squeeze it and finish by the end of March, hopefully. But that's what I hope we can do. But it really depends on what the speed ends up being like, because I also want to do enough practice, sufficient practice, so that you're able to understand all the details that we have in the topics. And for that, again, as I say again and again, it's really important that you are doing the practice questions as well. It's not just me who has to do all of these questions, because you'll start forgetting stuff if you don't practice yourself. So you have to do that. Okay, so yeah, that's it.
Sir?
I'll see you again. Yes.
Sir, can you please explain that point again where we have to multiply the coefficient of x square with negative to make it positive?
Okay, so I think I might have joined a bit late. So that was optional. That's not necessary. So, for example, this is an inequality that we were doing, right? This is one inequality. I think you joined just after this, if I remember correctly. So, if this is the inequality that we're solving, there are two ways of thinking about this. One possibility is that you solve it directly without changing the inequality sign. So you don't multiply it by negative sign at this point. You just treat this as an equation, solve that equation, and find the x-intercepts. When you find the x-intercepts, they are -4 and -3 in this case. Since the coefficient of x squared is negative, the graph is an n-shaped graph. And then using that n-shaped graph, you see, okay, the inequality sign is greater than or equal to. So you're looking for the part of the graph that is above the x-axis. That's this region. So the answer is between -4 and -3. Okay, that's one way of doing this. The other way of doing this, which I suggested, was that you could make this negative positive in the beginning. You multiply the inequality with -1 in the very beginning. When you do that, remember your inequality sign is also going to change. And then you do the same thing. You treat this as an equation, you find the x-intercepts, but remember in this case, since you made the coefficient of x squared positive, the graph is now a U-shaped graph. And the inequality sign has also changed. Now you have less than or equal to. So now we have a U-shaped graph. We're looking at the part of the graph that is below the x-axis, that's here. The answer turns out to be still the same. That's between -4 and -3. So both methods are going to work. Why did I suggest this? Because if you do it this way, you can kind of remember a rule in your head that whenever you have less than or equal to sign in this case, since it's a U-shaped curve, in a U-shaped graph, the part below the x-axis is always going to be in the middle, and the part above the x-axis is always going to be on the sides. So when you always make it a U-shaped graph like this, by making the coefficient of x squared positive in the very beginning for the inequality, then you could just remember this rule. So you might not sometimes need to even sketch the graph. You could just do it directly that, okay, if it's a less than or equal to sign, it's going to be the middle region. If it's a greater than or equal to sign, it's going to be the regions on the sides. but that's optional. You don't necessarily have to do it. This also works. This is equally good, right? So if you're used to doing it this way by just drawing an n-shaped graph in that case, that is also fine. Is that all right?
Yes, sir.
Okay, any other questions? No? Now, please make sure to complete the worksheet. Have a look at these questions as well that I've now added to the OneNote notebook as well. I'll be posting the recording as well, so you might find these questions in the recording there as well if you haven't taken the snapshot and you don't have notes downloaded either. So you have all of these questions. Please try to attempt them before the next class. Okay, we'll be discussing some of these in the next class along with the last concept that we have, which is disguised or hidden quadratic equations. All right, I'll see you again on Thursday. Allah Hafiz.